How a computer clock actually ticks. A sliver of quartz, 32,768 Hz, the raw tick of the whole machine. A quartz crystal, shimmering, a faint cyan waveform, one mono label, 32,768 Hz, that is layer 0 of the time stack. Playlist 0 was the whole map. This episode opens the bottom two boxes. The raw tick a computer counts, and the little clock that keeps counting it. Everything above is built on what happens here. At the very bottom of the stack is a sliver of quartz. Put a voltage across it and it flexes. Shape it right and it flexes at a precise frequency, exactly 32,768 times every second. That steady shiver is layer 0, the oscillator. That number isn't arbitrary. 32,768 is 2 to the 15th power. Engineers chose a power of 2 on purpose because it divides perfectly in half, again and again, in plain binary logic. Feed that 32,768 Hz shiver through 15 halving stages, each one a simple flip-flop, and out the end comes one clean pulse per second. That is where a second is born inside the machine, not from the sky, but from a crystal divided down. Hold on to this pulse. It is the raw unit of the whole series. The hardware clock counts it. The OS reads that count. We turn the count into a number. The network corrects the number. It all comes back to this one tick. Here's the catch. No real crystal vibrates at exactly 32,768, only very, very close. So two identical-looking clocks started together slowly pull apart from true time and from each other. The crystal is already very slightly wrong. Two things push it off. First, manufacturing. No two crystals are cut perfectly alike, so each has its own tiny built-in error. Second, and bigger, temperature. A crystal's frequency shifts as it heats up or cools down. We measure all of this in parts per million. Parts per million sounds reassuringly small, but run the arithmetic and an error of a few to a few tens of parts per million works out to order of seconds of drift a day, every day, forever. The point isn't the digit. The point is, it never stops. Counting the tick is layer 1's job, the hardware clock. And there's a special one, the real-time clock, the RTC, with its own tiny coin cell battery on the motherboard. That battery means the RTC keeps a running date and time even when the computer is unplugged. At boot, the operating system reads the RTC exactly once to learn the rough time of day. Then it lets go of the slow RTC and switches to a much faster counter on the CPU itself, the TSC or the HPET, to get fine, high-resolution ticks. Step back. Every piece works. The crystal, the divider, the RTC, the counter, and the clock still drifts because the tick underneath is never exactly right. A computer sitting alone can keep time, but it can never keep the right time by itself. That is why the rest of this series exists. The tick is real. The time is already drifting. Next, Episode 2, the OS clock, wall time versus monotonic time. Time is a stack, not a number.